Okay, so in order to understand those equivalent expressions, I first like to introduce them with these algebra tiles. So you have to first think of like an X tile being like this green rectangle. Numbers are just these unit tiles. So if it's the number 49, like we have in our example, we would need 49 of those. And since it's 7x, I'm going to need 7 of these X tiles. So I'm going to pause for just a second while I get everything up here. We've got our 1, 2, 3, 4, and so on. So we've got these 7 X tiles up here. We need 49 of these, so I'm going to work on getting those out, but then I'm going to pause it so you don't have to wait here forever for me to do that. Okay, so now I have my 7 X tiles up there, but I also have my 49 unit tiles up here. So I want to know which of those expressions are the exact same thing. And so when we look at the first one, you can see that it's written a little bit weird, so we're going to kind of skip that one for just a second. But when you look at the second one where it says 7 times x plus the 7 times 7, that's exactly what I have modeled here. I have 7 times x, which just means the 7x. But over here on the right, when I organize those unit tiles, I organize them into 7 groups of 7. And so you can see that that's the same as that 7 times 7. In order to understand what else it's equivalent to, so I'm looking at that first one where I see the 7 and then parentheses x plus 7. And what that really means, when you see that parentheses, that means I have a group, and in that group I have an x tile, and I have 7 unit tiles. But the 7 outside says I don't just have one of those, I actually have 7 groups that look like that. So there would be our second group, our third group, sorry, it's not cooperating very nicely, our third group, fourth group, fifth group, sixth group, and seventh group. And now that I have my 7 groups with each of those groups containing the X tile and the 7 unit tiles, you can see what does it look like when you actually count up all the tiles and see we've got 1, 2, 3, 4, 5, 6, 7 of those green tiles, just like we had before. And we have 7, 14, 21, 28, 35, 42, 49 of those yellow tiles, just like we had up here too. So when you're looking at those equivalent expressions, you're really just saying, okay, this is the number of algebra tiles that I have. This is what it looks like. When I lay out all of the other ones, do they look the same? Do I have the same number and same pieces of tiles? And so for the next one, where we have 13 plus 12y minus 7 minus y, it's really hard to model that subtraction with algebra tiles, and so we model it with negative tiles instead. But the 13 is going to be represented with 13 of these guys. Again, it'll take me just a second to get them up on the screen, so I'm going to pause while I finish that up. And 12y means we're going to have, oops, wrong one, we're not going to have 12 x's, we're going to have these y ones. And notice how similar they are. The y is still just a rectangle, so no matter what variable we're using, we're still going to be using rectangles, but the rectangles are different sizes. So just imagine every of those variable is just going to be a different size rectangle. I'm going to pause for a second while I get all of this up here. Okay, and now that it's all up here, you can see that I've got my 13 yellow tiles, so that's the 13. I have the 12y, so I've got those 12 purple tiles that represent the y's. And again, like I said, we can't really model the taking away very nicely, that subtracting 7. So instead, I'm going to actually model negative 7. And negative y means I will be taking away one of those y's. Now, in order to really show that subtraction, because now it looks like we just have extra tiles and it's not that we're really subtracting, a positive and a negative, those zero out, so those are gone. So I can pair up each one of these positive and negative tiles and know that they are all going to be zeroing out. Right? So that's like showing the 13 take away 7, which does leave us with just 6 left. All of these ones are just 0, so they don't even matter anymore. And our 12y take away one of those y's, well, same type of thing. We've got our y paired, or a negative y paired up with the positive y, and those will also end up zeroing out. So the 12 take away one of the y's gives us 11y. So as you're kind of looking through each one of those different expressions, which are the ones that are going to match and show the same number of tiles, here's all of the tiles that we had to begin with, model each one of the answer options, and see which ones end up with the same thing. Hopefully that helps. If not, then feel free to email me again.